Good day, guys. This is your tutor engineer. Today I'm back. I'm gonna do a trigonometry with you. So this is for really grade 12 and grade 11 level. So I'm just gonna do this example in front of you now. So when you approach proving identity, like proving trigonometry for the left hand side and the right hand side, if they are okay, they're the same basically. You have to take the most complicated side. So now look at this. You have the left hand side and then you have the right hand side. So here the most complicated side, you would agree with me, that would be the left hand side. So I'm going to write and simplify the left hand side. Eventually I'll have to see that it's the same as the right hand side. So look at the numerator there. You have cos 65x cos 63x. So sine 65x, sine 63x. I want you to notice the pattern. You have cos of 65, you have sine of 65. You have cos of 63x, you have sine of 63x. So that should remind you of a compound angles. Luckily, I have a formula sheet in front of me. So that should remind you of something like that, right? Right? So it's something like here. So in our case, we've got 65x, we've got 63x. That will be your alpha and your beta. So in the middle, you have plus. That means you're going to have minus, right? When you simplify it. So I'm going to simplify it according to that formula. I'm going to write this as cos 65x, which like is my alpha, minus, right? So if you have a plus, that means you're going to put minus here. 63x. So all of that is divided by the bottom, right? 1 plus sine 2x. So if you want, you can change the sine 2x to 2 sine x cos x, which is the double angle definition, right? So let me just show you in case you're not sure about that. So I'm using that formula here. So I just change it to that. Okay, let's go back. So let's continue with this, right? So the numerator is going to give me cos 2x, right? 65x minus 63 is 2x over 1 plus 2 sine x cos x. Okay, so now the next thing would be, remember, I'm trying to achieve that. That's the whole aim, right? So cos 2x, I can replace it with the cos squared x. It comes closer to what it's supposed to be there. Minus sine squared x, right? Divided by. You see the 1 here? So do you remember even from grade 11 where you learned that sine squared x plus cos squared x is equal to 1? So that's how I'm going to replace the 1, right? Going to replace the 1 by the same definition, which is sine squared x plus cos squared x. I still have 2 sine x cos x next to it. And then you realize that on top you have a difference of 2 squares. I can factorize that further, right? And then here at the bottom, you should be recognizing a trinomial, right? Like a quadratic trinomial of some sort. So a difference of 2 squares would be cos x minus sine x on one bracket, and then cos x plus sine x on another bracket. That's all divided by the trinomial. Okay, first of all, let me just rearrange this trinomial on the side. So think of that trinomial as, let me say, it's cos squared x plus 2 sine x cos x. I'm just rearranging it so that you can recognize it, right? So you can factorize this, right? So if you factor this, that would be cos x plus sine x. So that would be squared, right? Or you can just write it as 2 brackets like this, like cos x plus sine x. That's one bracket. Then another one would be cos x plus sine x. Okay, and then from here on, you realize that, okay, these brackets and that bracket look exactly the same. So they can divide each other out. So now you're only left with cos x minus sine x divided by cos x plus sine x. And that's exactly like what you have on the right hand side. So that's the end of our proof. So stay tuned for the next video, guys. I'll be posting more videos almost every day now. So subscribe and like the video. I'll post more content for your own benefits. I'm here for you. Thanks for availing yourself and have a nice day going further.